r is equal to 4. So let us see the general formula. In the second order, we have to calculate k1 and k2 only, and then we could calculate the approximation of y, first approximation, second approximation, by putting the values of different n. In RK method of order 4, we have to calculate k1, k2, k3, k4. So the general formula to find out the approximate value of y is given by k1 is h times f of xn comma yn, k2 is h times f of xn plus h by 2 yn plus k1 by 2, k3 is h times f of xn plus h by 2 comma yn plus k2 by 2, k4 is h times f of xn plus h comma yn plus k3. Thus, the yn plus 1 is given by yn plus 1 by 6 times k1 plus 2k2 plus 2k3 plus k4. Now, substituting the value of n here as 0, we get k1 as h times f of x naught y naught, k2 as h times f of x naught plus h by 2, comma y naught plus k1 by 2, k3 as h times f of x naught plus h by 2, comma y naught plus k2 by 2, k4 as h times f of x naught plus h, y naught plus k3. Thus, we get the first approximation y1, that is y at x1, as y naught plus half of k1 plus 2k2 plus 2k3 plus k4. Now, if we put n is equal to 1, we will get the second approximation, that is y2, which is y at x1. So, by calculating the new k1, k2, k3, k4, we can find out y2, which is equal to y1 plus 1 upon 6 times k1 plus 2k2 plus 2k3 plus k4. And so on, we can calculate the third and the fourth approximation as it is required in the question. So, let us consider one question. Using RK method of fourth order, we need to solve the IVP 3x plus y square with the initial condition y at 1 is equal to 1.2. At x is equal to 1.1. That means you have to find out the value of y at 1.1. Again, what is given in this question? X naught is 1, y naught is 1.2, f of xy is 3x plus y square. Here h is not given to us, so we can assume our h to be 0.1, so that we can just apply RK method of order 4 just once and we could find out the approximation at x is equal to 1.1. So find the value of y at 1.1, which is y at x1. So here what is our x1? x1 is x naught plus h. X naught is 1, h is 0.1, so we'll get the value as 1.1. Now, using the RK method of order 4, we have to calculate k1, k2, k3 and k4, and then we will be able to find out y1. So, what is k1 here? k1 is h times f of x naught comma y naught. F of x naught comma y naught is 3x plus y square. So, I have just substituted x naught y naught there and I will get my answer as 0.444. On the similar basis, I'll calculate k2 h times f of x naught plus h by 2, comma y naught plus k1 by 2. Now, what is x naught plus h by 2? First, let us calculate that. So, on this sticky note, you can see that I have calculated it separately. X naught is 1, h is 0.1 divided by 2. So, I am getting x naught plus h by 2 as 1.05. Y naught plus k1 by 2 would be y naught is 1.2. K1 is 0.444 that we have just calculated above. Divided by 2 would give me 1.422. So my f of 1.05 comma 1.422 would be, in the function I will put in place of x I will substitute 1.05 and in place of y I will put 1.422. So calculating the values, I'll get K2 as 0.5172. Now K3 would be h times f of x naught plus h by 2, y naught plus K2 by 2. So again, I have calculated it separately. What is x naught plus h by 2? It is previously done. So it is again 1.05. Y naught plus K2 by 2. K2 is 0.5172 that we have just calculated above. So y naught plus k2 by 2 is coming out to be 1.4586. Putting all these values in the function, I'll get my K3 as 0.52775. Now, K4, that is the last one, would be h times f of x naught plus h, y naught plus K3. So, x naught plus h would be 1 plus 0.1, that is 1.1. Y naught plus K3 would be 1.72775. Now, putting all the values, I'll get my K4 as 0.6285. Now, y1 is y0 plus 1 upon 6 times k1 plus 2k2 plus 2k3 plus k4. So, putting all the values of k1, k2, k3, k4 and y0 in this, I'll be able to calculate y1, that is y at 1.1. So, which is coming out to be 1.727067, which is approximately, if we'll take up to 4 or 3 decimal places, it would be 1.7270 7. I can take it up till 5 decimal places. So this is the approximate value, and this is the first question of RK method of order 4. In the next lecture, we'll be talking about another question of RK method of order 4. Thank you so much.